Today, let's do some sample problems that have to do with operational amplifiers. So our first one here is a difference amplifier, and what we want to do is find the output voltage. First, let's start by finding the voltage at the input terminal of the op-amp. We can do this by using voltage division. So we have 25 volts, and we want to multiply that by 3 ohms over 3 ohms plus 5 ohms. This gives us 9.375 volts. And that's going to be the same on the negative side, because in an op-amp like this, your voltage at each terminal is going to be the same. Next, let's find the current through this 15 ohm resistor. We can find this using Ohm's law, where current is equal to voltage over resistance. So our voltage is going to be the 30 volts connected to the resistor minus the voltage at the negative terminal, minus 9.375 volts, over 15 ohms. And that's going to give us 1.375 amps. In this op-amp, the current at both of the input terminals is 0 amps. There's no current here. So the current running through the 15 ohm resistor is going to then take this course of path through the 20 ohm resistor. So the current's going to be the same between both resistors. So yeah, we have current through the 15 ohm resistor is equal to current through the 20 ohm resistor, and that's 1.375 amps. Now we can use Kirchhoff's voltage law to find the output at VO. So VO is going to equal the voltage at one of the input terminals minus 20 ohms, because we have that 20 ohm resistor here, times the current. And our voltage is 9.375 volts. And this is going to give us negative 18.125 volts at the output terminal. And there's our answer. Next, we have this summing amplifier. What's the current I? Remember, in the last one I said at the input terminals the current is 0. But what's the current here, IF? Because this is a summing amplifier, we can solve for IF like this. We have IF, that's going to be equal to V1 over R1 plus V2 over R2. And this is our R2. So we have 2 volts over 4 ohms plus 3 volts over 8 ohms. That's going to give us 0.875 amps. So now we can find our output voltage. That's going to be equal to our IF value times our RF value. RF is going to be this resistor here. That's 8 ohms. And we want to make sure we remember the negative sign in front of our current, because current flows in the direction of high potential to low potential. And we want to assume that our output voltage is going to be of a lower potential than what we have here at the inputs. So we get negative 0.875 amps times 8 ohms That's going to give us about negative 7 volts. And you see negative 7, that's less than the voltage we have at the input. If this were a positive 7, it would make no sense for the current to be moving in this direction. All right, on to the last problem. Okay, so now for this ideal op-amp, what should the value of this resistor be in order for us to obtain a gain of 5? First, let's find the voltage at the positive input terminal here on the op-amp. We can do that through voltage division. So V plus is going to be equal to V in times 2k ohms over 1k ohm plus 2k ohms. And this is simply going to give us 2/3 times VI. Now, like I said before, the voltage is the same at both of these terminals on the op-amp. Now let's find this current running through this 3k ohm resistor. So I will be equal to the voltage here on the negative side divided by the resistor, 3k ohms. This is Ohm's law. Current is equal to voltage over resistance. So this gives us 2/3 times VI over 3k ohms. Now, we don't know what VI is, but we do know that we're trying to achieve a gain of 5. That means our output voltage over our input voltage is going to be equal to 5. And we can rearrange this to be output voltage is equal to 5 times the input voltage. So that'll be useful information that's going to help us out. Let's find this current, IF. IF is going to be VO minus the voltage at the negative terminal here divided by RF. And because this op-amp draws no current, this current and this current is the same. So we can set these two values equal to each other. So we have VO minus the voltage at the negative terminal divided by RF is equal to 2/3 times VI over 3k ohms. We know what the voltage at the negative terminal is, and we can replace this VO with 5 times VI. So now we have 5 times VI minus 2/3 times VI over RF is equal to 2/3 VI over 3k ohms. Now we can subtract these two, which gives us 13 over 3, and then we were able to cancel out the VIs. So see, we didn't even need to know what the value of that was. So now we have 13 over 3 all over RF is equal to 2/3 over 3k ohms. And if you do the math on that, or type that into a calculator, or however, we get RF is equal to 19.5 k ohms. So we found the value of our RF resistor that got our op-amp to attain a gain of 5. Hope you enjoyed, and thanks for watching.